I heartily welcomes you all in today's session of Mechanics of Solids. I am Professor Mohammad A. Qureshi, working as an assistant professor in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. Today, we will learn about parallelogram law of forces. Why we are using parallelogram law of forces? Because we have to find out the resultant force, and this is one of the methods for finding the resultant force. This method lies under the category of analytical methods. We have three methods for finding out the resultant force. First method is parallelogram law of forces. Second method is resolution of forces. And triangle law of forces is the third method. All the three methods are useful for finding the resultant force. Also, we can find the resultant force by graphical methods. There are two methods in graphical way. First one is triangle law of forces and second one is polygon law of forces. So first we will study about parallelogram law of forces. It states that if two forces, suppose this is your one force denoted by P and the other force is Q. Okay, so now we have two forces acting simultaneously on a particle. So we represent the particle as O. Two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent side of the parallelogram. By the two adjacent side of the parallelogram. This will be your Q force. Then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram. Means diagonal represents the resultant force and which passes through their point of intersection, and which passes through their point of intersection means which passes through point force P and force Q. So finally it states that if two forces, your P force and your Q force, acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of the parallelogram, then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. Now, one most important thing, this angle will be represented as theta. Will be represented as theta. Remember one thing, theta will be the angle between the two forces. Which force? The given force. Here the given forces are P and Q. And one more thing, this angle will be your alpha. What is alpha? Angle between resultant force and any one of the two forces. So your alpha will be the angle between P and R. Now we will just modify this figure. So here your Q force is already be represented in this direction, and this will be your angle theta, Suppose this is your A point, this is your B point, this is your C point, and this will be your D point. So in that case, the distance AD will be Q cos theta, and the distance CD will be your Q sin theta. So in this case, what is R? Resultant force. What is P? One force. Q, the other force. Theta, the angle between the P and Q force, and alpha, the angle between P and R force. So resultant force will be find out by the equation capital R equals to under root of P square plus Q square plus 2PQ cos theta. So you can find the resultant force by this formula. Capital R equals to resultant force equals to under root of P square plus Q square plus 2PQ cos theta. And you have to find the value of alpha, the angle between P and R alpha, by the equation tan alpha equals to Q sin theta upon P plus Q cos theta. You can find the value of alpha by using this equation. What is angle alpha? Angle alpha is the angle which lies between or which creates between the resultant force and your one of the forces. So now we will go through the examples of parallelogram law of forces. So what we have given in this example, two tensile forces. Which forces are there? Tensile force. We have discussed earlier that there are two types of forces. One is tensile force and the another one is compressive force. Here it is given that two tensile forces means both forces are acting away from the point, or both forces are acting away from the object. So two tensile forces 50 kilonewton and 40 kilonewton. One force is given as 40 and the other force is denoted as 40 kilonewton. Acting at a point, both forces are acting at a point with an angle 60 degree between them. What is 60 degree? Angle between 50 kilonewton and 40 kilonewton. So we can say that this angle is nothing but theta. So theta will be your 60 degree. And lastly, they have given that find the magnitude and direction of the resultant. We have to find the magnitude of resultant as well as the direction, means alpha of the resultant. So first of all, we will write the given data. So let us assume that P force is 50 kilonewton and Q force is 40 kilonewton, and angle is given, that is theta is given as 60 degree. So we have considered 50 kilonewton as P force, 40 kilonewton as Q force, and angle between P and Q force, that is theta, is 60 degree. So now we are using the parallelogram law of forces. So first of all, we will plot the parallelogram. Here P is 50 kilonewton and both forces are tensile, means they are going away from the object. So this will be your Q as 40 kilo Newton. Now we will complete the parallelogram. So, as per parallelogram law of forces, we know that resultant will be represented by the diagonal of the parallelogram. So, here we can write capital R, and the angle between both the forces is 60 degree, and we have to find the value of alpha as the direction of the resultant. So now we know that resultant capital R equals to under root of P square plus Q square plus 2PQ cos theta. We have this formula. So now we will put the value of P, Q and theta in this equation. We have given capital P as 50 kilonewton. So 50 square plus Q as 40 square plus 2 as it is into P, value of P as 50 into value of Q as 40 into cos value of theta is 60 degree. So here we had put all the values that are required in the given equation. So by solving this, we will get the value of resultant as under root of 6100 kilo Newton. So after finalizing it, we get 78.10 kilo Newton. So we had find the value of resultant, that the magnitude of resultant is nothing but 78.10 kilo Newton. Now next, what we have to find? We have to find the value of direction of the resultant, means we have to find the value of alpha. So in that case, we have the formula tan alpha equals to q sin theta upon p plus q cos theta. So now again, putting all the values of p force, q force and theta force in this equation, we will get 40 sin 60 upon 50 plus 40 cos 60. After solving this numerator as well as denominator, we will get the value of tan alpha as 0.595. And then finally, we will get the value of alpha as 26.33 degree. This alpha made the angle of resultant with P force. Hence, your alpha will be 26.33 degree. So, now our example is complete. There is simple formula for finding the value of resultant. Capital R equals to under root of P square plus Q square plus 2PQ cos theta. And after putting all the values of P, Q and theta in this equation, we will get the value of resultant as 78.10. And by using the second equation, tan alpha equals to q sine theta upon p plus q cos theta, we will get the value of alpha as 26.33 degree. So this is the simple method and simple step for finding the resultant of the given forces. Now we will go for second example. What is second example? Two tensile forces 100 kilonewton and q kilonewton. Here the magnitude of q is not given, but it simply states that it is q kilonewton, and both forces are tensile, means both forces are going away from the object or from the point. So two tensile forces 100 kilonewton and q kilonewton acting at a point at an angle 90 degree between them. Here theta is given as 90 degree. Then if the resultant force is 200 kilonewton, in previous example we calculate the value of resultant force, but in this example the resultant force is already given as 200 kilonewton, and we have to calculate the value of q. That is, we have to calculate the value of a known force q, and also we have to find the angle made by resultant with 100 kilonewton force. So now we will begin. Here let us assume that P equals to 100 kilo Newton. Then Q is unknown, value of Q is unknown for us. Then capital R equals to 200 kilonewton. Then theta is given, angle between P and Q is 90 degree. So first of all, we will plot the figure for the above example. So as the angle between both forces are 90 degree, here P equals to 100 kilonewton, Q is unknown, therefore we will simply write Q, and then we will enclose all the side to make the parallelogram. Then the resultant between these two forces is given as capital R equals to 200 kilo Newton. And the angle between both the forces, that is theta, is given as 90 degree. And we have to find the value of alpha. So value of P is given already, and value of capital R is also given. We have to find the value of Q. So now, first of all, we will use the above equation for finding out the resultant force, that is capital R equals to under root of P square plus Q square plus 2PQ cos theta. Now we will put the values that are given in the statement, that is value of R is given as 200 under root of value of P is given as 100 square plus value of q is unknown and we have to find this value. So we will simply write as q plus 2 into 100 into q into cos 90. So here 200 equals to under root of 100 square plus q square plus 0, because cos 90 is nothing but 0. Now our next step will be 200 square. We are squaring on both the side, equals to 100 square plus q square. Hence, capital Q square equals to 200 square minus 100 square. Therefore, the value of Q will be 173.20 kilo Newton. Now, next step, we have to find the value of alpha, because in the statement it is given that also find the angle made by resultant with 100 kilonewton force. So now we know the equation that tan alpha equals to q sine theta upon p plus q cos theta. We have the value of q as 173.20 into sine, and value of theta is given as 90 degree, upon value of p as 100 plus value of q as 173.20 into cos 90 degree. So we will get 1.73. The value of tan alpha will be 1.73, but we need the value of alpha. So your alpha will be tan inverse of 1.73. Hence, your alpha will be 60 degree with 100 kilonewton force. So this way you may easily calculate the value of any force as well as the value of alpha, that is the angle made by resultant with any of the forces. So in this lecture we had learned about the parallelogram law of forces, and we had solved the example related to parallelogram law of forces by simple two formulas, that is capital R equals to under root of p square plus q square plus 2pq cos theta, and tan alpha equals to q sine theta upon p plus q cos theta. In next lecture we will go to different method for finding the resultant force in analytically. Resolution of forces and triangle law of forces will be discussed in next lecture. Thank you very much.
$25 मिनट